Now we're going to start looking at solving equations involving sine, cosine, or tangent. Now, I'm just going to jump into my class example number 5, and the reason I'm doing that is because we're going to be using, we'll end up reading and applying this method to solve this question here. So we want to use the procedure above to solve sine theta is equal to 0.5, where my angle theta is between 0 degrees and 360 degrees. All right, so we know that it is somewhere on this quadrant, and we just know it's not going to be greater than 360 degrees or less than 0 degrees. So it's being rotated in standard position. Now, step 1, we want to determine the quadrant or quadrants the angle will be in by looking at the sign of the ratio. So my ratio is right here, and the sign is positive because there's no negative. So we know that it has to be either in this quadrant or in this quadrant because we're looking for the sign ratio as well, right? These are the only two quadrants. If I were to add sugar to coffee, these are the only two quadrants where the sign ratio is positive. And so we know it has to be in either quad 1 or 2. Now what we want to do is determine what the reference angle is going to be. So determine the reference angle, always between 0 and 90 degrees, and draw a rough sketch in the appropriate quadrant. Now to determine the reference angle, we want to use second sine because we're using sine theta to determine the reference angle. And we want to use and we want an absolute value of the given quantity, so it's going to be positive that we're looking at. So because again we're using the sine ratio, second function, and then we press our sine button, and then I want to type in my ratio, which was 0.5 in this case. So we have a reference angle of 30 degrees. All right. So my reference angle is equal to the inverse sine of 0.5, and that's equal to 30 degrees. Now we want to determine the rotation angle using the reference angle and the quadrants. So for quadrant 1, that's going to be equal to 0 degrees plus the reference angle, which is 30 degrees. That just gives me 30 degrees. For quadrant 2, we're looking at 180 degrees, right? So there's my 0 degrees, and 180 degrees minus 30 degrees, giving me 150 degrees. And so those are the two possible angles that it could be for theta. So theta is equal to 30 degrees or 150 degrees. With class example number 6, find the measure of x to the nearest degree where x is between 0 degrees and 360 degrees. And again, we're going to be using the exact same procedures we used for this example here. So step 1, we want to determine what quadrant it's in, and I'm just going to do B. So step 1, cosine x. Now cosine x is negative here, so that means it can't be in quadrant 1 or quadrant 4. That means it has to be in quadrant 3 or quadrant 2 or 3. All right. And now we want to determine what the reference angle is. So my reference angle is going to be inverse cosine, because we're using cosine now, negative 0.8090. Negative 0.8090. Absolute value, right? So cosine negative 1.8090, and we want to use the absolute value, so we can't use the negative ratio, we want to use the positive ratio. And so my reference angle is going to be 36 degrees. And so for quadrant 2 here, so quad 2, that's going to be 180 degrees minus 36 degrees, which gives me 144 degrees. And then for quad 3, we have 180 degrees plus 36 degrees, which gives me 216 degrees. So my angle can be either be 144 or 216. Now, we're going to be looking at class example number 8. A and B are exactly the same what we were doing in the previous examples, but class example number 8 looks a little bit different. So this time we want to solve the equation 3 times tan theta plus 1 equals 4. Now, before we solve this one, there's a little bit of rearranging that we need to do. So I'm given an equation, 3 tan theta plus 1 equals 4, and we're solving for theta, right? That's our unknown value that we're solving for. And right now, it looks a little bit confusing, but this is just an algebraic expression that we can solve. So the first thing I got to do is subtract 1 from both sides. All right, so subtract 1 from both sides. I'm left with 3 tan theta equals 4 minus 1 is 3. And then I want to divide by 3 on both sides to get this tan theta by itself. Just so it looks kind of like this, just no variable attached to my trig ratio and angle. So dividing both sides by 3, I'm going to get tan theta, 3 divided by 3 is 1. And so if I draw, so my first procedure here, first of all, I have a positive trig ratio, and so if tan theta is positive, then I know it's going to maybe be either here or maybe over here. But yeah, if I'm looking for the absolute value of that as well, so inverse tan of 1 equals 45 degrees, right? And so, and it can't be in this quadrant, because if we look at this, we're looking at between 0 and 180, so it has to be in between this plane here. And so if I find the reference angle for tan of the inverse tan of 1, we get 45 degrees, and that would just be right here. And so my actual angle, is 0 plus 45, or 45 degrees.